From the beginning, green chemistry has been about finding ways to make the things we use cleaner so that modern economies can operate in harmony rather than conflict with our environment. But improvements created through green chemistry have also yielded tremendous economic benefits. Green chemistry offers a way to improve performance, efficiency, and the bottom line at nearly every stage of the production of the things we use. This power comes from a combination of two factors. First, thoughtful design is applied at the very beginning of a process. Smart choices made here will echo out into countless economic advantages here. Second, chemists have the power to look at a product at its most basic molecular level. Apply thoughtful design at the very beginning and at that level of detail, and you create the ability to influence the environmental and economic performance of what follows in unparalleled ways. Let's look at an example. Imagine that the researchers at this facility used green chemistry to develop a cleaner, smarter way to make their product. Their design would have the potential to improve nearly every stage of the production process. This, of course, is a pretend scenario, but the changes we'll discuss are drawn straight from real-life green chemistry success stories. Let's start at the beginning with the raw materials. This facility needs 6 main inputs to make its product. In redesigning the product at the molecular level, the green chemists might create a way to make the product using just 3 inputs. This would lead to significant efficiencies throughout the facility's inventory control system. Now consider that 2 of the remaining inputs are hazardous materials. The new design could make it possible to create the product with only benign inputs. Getting rid of the hazardous inputs would improve worker health, remove the need for expensive hazardous materials handling procedures, and reduce the company's risk and regulatory exposure. And if these storage tanks were no longer full of hazardous materials, the facility would enjoy improved chemical site security. Inside, the old production process uses 6 steps and includes one stage that requires significant amounts of heat and another that needs constant mechanical stirring. The green chemistry redesign could make it possible to create the product in just 3 steps, freeing up valuable space that can be dedicated to future growth. And the green chemists might also design new chemical reactions that can happen at room temperature and without constant stirring. These improvements would significantly reduce the facility's energy costs. Now let's take a look at product yield. It's not uncommon in many industries for perhaps 10% of the volume of the inputs to end up in the final product. History has proven that the green chemists in our story might be able to increase those yields to 50, 60, 70%, or perhaps even more. A tremendous benefit, as more of the costly inputs would go into the product and less into the waste stream. And speaking of waste, the chemical used to drive the reaction in this tank can only be used once. When a batch is complete, it just has to be sent away as waste. The designers might instead choose a chemical that doesn't get worn out. At the end of each batch, it can be returned to the beginning to do the job again. This improvement would slow the related input and waste streams to a trickle and greatly reduce all related costs. These are just some examples of the benefits that green chemistry has made possible around the world over the last 25 years. So if you're looking for environmental and economic benefits at any stage in a product's life cycle, start here, where thoughtful changes in design are likely to yield profound benefits all the way down the line.